My topic will be how to measure direct current voltage, alternating current voltage, and frequency of a power line. For direct current voltage, I will show you how to measure the battery voltage of a 9-volt battery. This is a 9-volt battery. For a 9-volt battery, there are two terminals. The bigger terminal is actually the positive one, and the smaller one is the negative terminal. So actually, to measure the voltage of this 9-volt battery, okay, what we have learned from the use of a multitester, we set the multitester in the volt DC range, volt DC, okay, volt DC. Then we will connect the negative terminal on the smaller one, right? And hold on. The black terminal is actually the common, the black one. Then the red terminal on the bigger one. So after setting the, hold on. So after setting the voltage to voltage DC, you connect the two terminals. Okay? The reading of this battery is 9.98 volts. I think it's a negative thing. Hold on. Hold on. Yeah. Sorry for that one. The smaller terminal is actually the positive one, and the bigger terminal is actually the negative. That's why the reading that comes out now is actually 9.98 volts. It's positive. So meaning we connect the terminals on the proper polarity, meaning the positive to positive and negative to negative. That is a positive 9.98. I will show you the connection or the reading with the wrong polarity. I will try to interchange the red and black over here, and what will come out will be a negative reading. Hold on. I interchanged the connection, right? The reading a while ago was the correct reading because the reading was a positive 9.98. And now the reading is 9.98 preceded by a negative sign. Okay? The value of the voltage is still the same, but we connect the connection to the battery wrong. So it doesn't matter if it is wrong, it just indicates that we made a wrong connection. The battery will not explode, okay? Or the multitester will explode. It just shows that the negative sign indicates that we connect the terminal of the battery on the tester terminals wrong. So that's the significance of the so-called polarity. That's the meaning of polarity in direct current voltage. Even in the measurement of direct current, there is a polarity. If you connect it wrongly, there could be a negative reading, and that negative reading indicates a wrong polarity. So for the measurement of voltages, okay, if there is a negative reading, your connection is wrong. You just interchange what you connect, okay, on the terminal of the battery and the terminal of the tester, and what will come out will be positive reading. So if it's a positive reading, that's the correct connection. Okay, I will try to bring back the original reading which is positive without the negative sign on the side. So I will interchange again this one before we will go to the other topic. So the reading now after interchanging, the voltage now is 9.98 without the negative sign on the side. Right? So that's positive. So our connection is actually correct. That's the correct polarity. The smaller terminal will be the positive terminal for a 9 volt, and the bigger terminal, meaning it's just like an air, right? It's wider one. That's the negative one. Okay? That's the proper way on how to measure direct current voltage and how to determine if your connection is wrong or not. Okay, let's try to measure an AC voltage. This is a little bit dangerous because I will be measuring 120 volts AC coming from this convenience outlet. Okay, that's why I wear my gloves. Okay, if I will be measuring in an AC voltage and which is more dangerous, so I will be changing my cord. Okay, this is the correct what you call this instrument for measuring AC voltage, which is more dangerous. So for this one, these are just good for battery. Okay. So I have a negative terminal, a negative cord, a positive cord, red terminal, and I have a negative terminal which is colored black. Okay. I will switch on this switch over here. Okay. And I will change the location. Hold on. The location of the voltage to be measured. I will put the tester on voltage AC. Okay. So I am now ready. I connect it. I connect the red thing to the plus terminal and the black cord to the common ground. So this is for the common ground. This is the live circuit for the live circuit. So I switch on the outlet now. The power voltage here in California is almost 120 volts AC. And later on, we will check if the frequency is actually 60 hertz. Okay? I will poke the ground thing. Then I will poke the red thing. Okay? The reading is 118.1 volts. That's AC. 118.1. So it's a little bit low from the so-called standard 120. There are voltage drops on the line because supposed to be this is 120 volts. But 118.1 volts will not hurt our equipment that is plugged in. It is just that the call this the efficiency of the lines are not so good. That's why from the post that contains our transformer that supplies our house, there's a voltage drop from there going to the house. Because the voltage is supposed to be 120 volts AC. And what comes out is only 118.1. Okay? It's 118.1. I will show you the connection. Okay? That's the terminal. Okay? So for measuring AC voltage, put the pointer on voltage AC and you connect the plus and minus on the terminal on the outlet. Actually, since this is alternating current, we could interchange the location. We could interchange. I will interchange. Okay. I will place the red one first. Okay. Then I will place the negative one. Okay. it goes 117. So actually our voltage right now is actually fluctuating because a while ago, uh, when I then interchange the location of the because you could actually interchange the location of the black and red, there is no problem because there is no polarity in alternating current circuit because in every 60 seconds, okay, the what you call this, the polarity of the plus and minus interchange every 60 times a second, 60 hertz a second. It try to alternate 60 times a second. So actually, you don't have to follow the polarity, unlike on the battery. Okay, the red should go to the plus terminal and the black should go to the negative terminal. But in here, it doesn't matter where you poke, right? We are not following any polarity in AC measurement. That's the difference between direct current measurement and alternating current measurement. Okay? Oh, I changed the connection of the plus, the red and black. But the reading is still the same. And it doesn't say if it is plus or minus because there is no such thing as plus or minus in AC voltage, you know. In the alternation, there's the plus alternation, negative alternation, but the overall sign of the voltage are all positive for AC. Okay? Even though you interchange the connection. Okay? That's for AC. Okay, the next one to be, this is a very dangerous thing. That's why I wear gloves, you know. Okay, the next thing I will be measuring is the frequency. Let us try to see if the frequency of the power line here in California is 60 hertz. Okay, I will try to remove first. I will put my multi-tester on the pointer that will measure frequency. It is this. Okay. Then I will try to poke the red one. Then I will try to poke the black one on the terminal, on the outlet. Okay. And what is the reading? It is 59.9. Okay. And supposed to be, this is 60 hertz. Okay. But 59.9 is almost 60 hertz. So it just verified that the frequency here in California, here in the United States of America, the frequency is 60 hertz. But my measurement right now is 59.9. So there's a very minute discrepancy. We don't want to fight about it, right? 59.9 is almost 60. So I could say that the frequency of the power line here in California right now is 59.9 or almost 60 hertz. Okay, so those are the three measurements that are necessary when using a multi-tester. These are very dangerous measurements. And the voltage measurement for a battery, no problem because it's a low voltage. But in the measurement of alternating current voltage, which will come out from the convenience outlet, it's a very dangerous one. You could be killed if you miscalculate the handling of the tip of the tester, you know. So just be, what you call this, be protective with yourself when you're doing this one. Okay? So for the measurement of AC voltage, just take care of yourself. And the measurement of the frequency, just take care of yourself. Because you might get killed. 120 volts AC could kill us. Okay? Good morning from Los Angeles.